This is just the beginning of my experiments, and here we see a spot of solar radiation which comes from these cheap parabolic mirrors. At the same time, this side receives solar radiation too, but directly from the sun. This is a solar heater of ambient air, which comes inside the heater thanks to this fan. Here we see the air outlet, and this sensor tells us that solar energy heated the air to about 60 degrees Celsius. The purpose of my experiments is to create a very cheap solar air heater for similar long rows. I am trying to reach a situation where the heat of my solar heater is many times cheaper than heat from natural gas. If the purpose will be achieved, our hot air can be used for space heating a house or greenhouse, or for various industrial processes including drying. We understand that our solar heat will be very cheap if our solar heater is several tens of times cheaper than traditional solar collectors. This is a list of materials for making my solar heater, and we can calculate that it is about $5 per square meter of the heater. I remind you that this solar concentrator uses materials worth about $5 per square meter of mirror. However, I am trying to create even cheaper solar concentrators. Let's look at how I built this solar heater. We see that at first I hammered 2 batons into the ground and put on a transparent polyethylene film. Now I show how I put on the film, but I want to warn that this method has several disadvantages. Therefore, I recommend using other methods for installing the transparent film. We see that I connected this wooden batten with expanded polystyrene using polyurethane foam, and these screws fix the batten. Then I installed this wooden board using these screws. After that, we have to install sheets of thin aluminum foil. Now I show 3 steps of installing the foil. Obviously, both sides of the foil must be coated with black paint, which is able to withstand temperatures of 200 degrees Celsius. Then we fix the edges of the transparent film. These are the final stages of building my solar heater. Let's look at the temperature of the black aluminum foil. We see that the sun can heat the foil to a temperature of more than 180 degrees Celsius. But the high temperatures exist only in areas where the solar radiation from the mirrors is focused. However, it is obvious that real air heating temperature will be much lower, and now we will measure it. Ambient air has a temperature of 12 degrees Celsius today, and the air comes inside the heater through this inlet. We understand that now the air moves through the heater due to the phenomenon of gravitational circulation and due to the wind. The air leaves the heater here, and the sensor tells us that the sun heats the air to a temperature of 75 degrees Celsius. It is obvious that now the air flow through the heater is small, because the fan is not installed. But now I installed the fan, and we see that the heating temperature of the air has decreased, because its flow velocity increased. Now I removed the fan, and we can again see the temperature of the air if it moves slowly through the solar heater. However, I think that the efficiency of our solar heater will be greater if we convert that black foil into a tube, which will be the path for air movement. In addition, we understand that this position of the solar heater is optimal for winter, when the sun is low above the horizon. If we plan to produce heat during high sun, the position of the heater should be different.